So let's look at these. What I like to do to help kind of organize myself with this, and you're going to need to be organized with this. You can't be like everywhere with three variable systems. You need to look at it and say, okay, well, this is equation number 1, this is equation number 2, and this is equation number 3. Okay, because we're going to have to take them 2 at a time to start off with. Okay, what we need to do in order to solve a three variable system is we need to get it down to a 2 variable system and get at least one answer out of that. Okay, so what we're going to do is we're going to take these 3 equations and we're going to pair up some stuff and try to cancel out one of our variables. It doesn't really matter which variable you cancel out first. You just kind of want to pick one and say, I'm going to get rid of the z's, or I'm going to get rid of the x's, or I'm going to get rid of the y's. And you have to, what you end up doing is creating a 2 variable system that can get you an answer out of it. Okay, so with this one, what I would do is I would take, when I'm looking at that and I say, okay, I want to try to get rid of a variable here. So the y's look like they'd be easy to get rid of because I got a negative y here, and then I got a 2y up there and a 3. So those look like they might be pretty easy to get rid of. So that's what I'm going to try to get rid of. And I'm going to do that using pairs. So what I'm going to do is I'm going to pair up equation 1 and equation 3 first. Okay? So I'm using 1 and 3. Eliminate y. Okay? So what I'm doing is organizing myself, telling myself what I'm doing. I'm taking equation 1 and 3, and I'm going to eliminate y. So I'm just going to recopy those equations. 4x plus 2y plus 3z equals 1. And then the third equation is 6x minus y plus 4z equals negative 1. Okay. Now, if I want to use elimination to get rid of the y, what does this y need to turn into? A 2, a negative 2 in fact. It's already got the negative, so what do I need to do to this equation here? Multiply that whole thing by 2. So this is where, I said yesterday in the last couple of days, you got to be able to do both methods because substitution with 3 variables is very, very long if you don't have the elimination to kind of help you shorten it up a little bit. So that changes that system to 12x minus 2y plus 8z equals negative 2. And then the top equation there doesn't change at all because I didn't need it to. Make sure I copied everything, right? Yeah. And then eliminate by adding these 2 things together. All right, so that's going to be 16x plus 11z is equal to negative 1. Okay, and I'm going to scoot that 16x over here so it looks like something, like it's supposed to look like. We've got an equation that has an x and a z in it. What we need to do now is take a different pair. We used 1 and 3 and got rid of y's. We need to use either 2 and 3 or 1 and 2 and get rid of y's. Well, I'm going to use 2 and 3 here because I know I can just multiply this second one by what? 3, and it'll cancel it out, right? So that's kind of the thinking we want to use. We're trying to get rid of y twice. Yeah, I'm going to have to use the negative 3, to get rid of that. So that's what I'm looking for to see which equation would I use here. So I'm going to use 2 and 3 and eliminate y. Okay, so 2 and 3 eliminate y. So I'm taking equation 2, 2x minus 3y plus 5z equals negative 14. And then equation 3, 6x minus y plus 4z is equal to negative 1. Multiply that second one, you guys are right, by negative 3. And that's going to give us negative 18x plus 3y minus 12z equals positive 3. And then the top one doesn't change.
So
Like equation number 2? Yeah, I didn't need to change it. Now, there may be times where you might need to multiply it by something to get something to eliminate. The idea here is that we're using, two different pairs and eliminating the same variable in those pairs. Okay, that's what you've got to do. You've got to get rid of the same variable twice. Okay, so that's what happens here. You got negative 16x. The y's cancel out. Right? That's a negative 7z equals negative 11. I'm going to scoot that over. All right, let's continue. Now, look at what I've got here. I've got two equations that have x and z in them. And it looks like they're going to be pretty nice to do elimination with, right? If I put those two together. And that will get me an equation that only has a z in it. Okay, so I'm gonna do those two as a system of equations. 16x plus 11z equals negative 1. Then we have negative 16x minus 7z, negative 11. The x's cancel out. 4z, negative 12. And then, z is going to be negative 3. Where can I go from there to get another variable? Like, what do you mean the top one? Yes, that's what we got to do. We've got to take this answer and plug it into either one of these. Because if we plug it back into the very original, they got 2 variables or 3 variables in there. There would still be 2 variables in it. It wouldn't give us an answer. We want to take this and go back into one of these. Doesn't matter which one. And that's going to get us the answer for x. Because we got z. And then we're going to get x. And once we get x, we can plug that back into the x and z back in and get the y value. Okay? So that's what I'm going to do here. I'm going to take this negative 3. That's 16x. 16x minus 33 is equal to negative 1. 11 times. Yeah, it doesn't matter which one you use. We should end up, that'll be a good way to check here if we end up with the same x value. So plus 33. 16x is equal to 32. X is 2, right? Is that what you got by using another equation?
I got negative 32. No. Yeah, I got negative 32. Oh, we should divide by 16.
If you use this equation, it should be negative 16 that you're dividing by.
Okay,
and it should still be ends up being positive there. All right, so now we got 2 of the 3.
Yes. I was just going to say, since you have the 2 of the 3, can't you plug it into one of the original equations and get the...
Perfect. That's right. You're going to since you got 2 of the 3, plug it into the original, work it out. So pick one of the originals to plug into. I'm going to plug it into the third one because it's got a pretty plain y there that I don't have to do much division with at the end. So we got 6 times 2 minus y plus 4 times negative 3 is equal to negative 1. So that was equation number 3 that I went into there. It doesn't matter which of the first 3 that you use to get. Plug it in, work that out, so that's 12 minus y minus 12 is negative 1. These cancel each other out. Negative y is equal to negative 1. So y is equal to, 12 minus 12 is 0, so it cancels each other out. And that's okay. Ordered triple, x, y, and z. X and negative 3. We got 3 variables, so we have an ordered triple is what that's called. Kylie. You could graph. If you'll look there on page 178, there's some... It's hard to do this by hand, but what you're looking at, when there's one solution like this, you're looking at where 3 planes, flat planes, intersect. The best example I can give you there is the corner of the room. The ceiling is one flat plane. This wall is a second flat plane, and that wall's a third flat plane. Up there in the corners where they meet, that's that one point, that one solution.
So it's 3D.
It's 3D. That's exactly right. We're doing math in 3 dimensions.
Wow. Doesn't that geometry? 12.
The geometry that we cover in high school is 2-dimensional for the most part. There is a section or two about three-dimensional solids, but not so much.
Well, I'm glad we didn't have to do geometry like this because I would have never had that.
All right, let's look at one more. We don't have time to do one more today. All right, this is what I want you to try to do. On page 182. I want you to try to work on page 182. I'm not going to give you many. I'm just going to give you a couple of them here. I want you to try to work number 9. Try number 11. And then number 12. Just those 3. 3 problems. 3 problems over